In this example, we're going to look at the same concept of instantaneous rate of change, only we're going to apply it to a different example that doesn't involve distance and speed and things like that. We're going to look at blood alcohol content. So a person's blood alcohol content is a measure how much alcohol is in a person's bloodstream. It's measured in grams per 100 milliliter of blood. And when a person stops drinking, the blood alcohol content declines over time as the alcohol is metabolized. And the graph shown here is the blood alcohol content of a person T hours after he stops drinking. So the first thing we want to do is find the average rates of change over these various intervals. And you can see we're doing something similar to what we did in the last example, where we're taking intervals that are closer and closer to 2. So if we're going to first of all look at the average rate of change from 2 to 4, and then 2 to 3, and 2 to 2.5. Now we're only given a graph this time, so it's a little bit trickier. It's a lot easier when we have a function. We just plug numbers in and calculate the values. But here we have to read it off the graph. So let's mark on here where some of these values are. So here's 2, and it's kind of looking like, let me just draw on what that point is. I'm going to say that this appears to be the point 2, 0.045. Okay, so it's somewhere between 0.04 and 0.05. So I'm just going to estimate where these values are. So I'm first of all just going to go through here and find out what these values are. Now 4 is down here, and it looks like this is the point 4, I'm going to say 0.02. It looks like it's pretty close to being right at 0.02. All right, the next one we're going to look at is 3. Looks like that one's pretty easy to read. This is 3, 0.03. And then, okay, then we're going to look at 2.5. All right, so 2.5 looks like it's right here. And I'm going to estimate that to be 2.5, let's see, it looks like it's, I'm going to say it's about 0.037. It's pretty close to 4. This is like 7.5, something like that. So I'm just going to say 0.037. So I'm just getting as close as I can. The last one we want to look at is 2.25. All right, so these minor grid lines are, 0.25 apart. So 2.25 is about here. If I come over, it looks like it's a little bit above 0.04. So I'm going to write it over here. This is the point 2.25, I'm going to say it's 0.041. All right, roughly. That's my best estimate. All right, so now I have my values marked, and then it'll make it easy to calculate those average rates of change. All right, so I'm just going to do one simple calculation, and then I'm assuming that you can do the average rate of change calculations yourself. But I'm just going to look at the first interval. So I'm going to look at the interval from 2 to 4. So the value at 4 is 0.02, and the value at 2 is 0.045, and I'm going to divide that by 4 minus 2. Okay, this is going to be my first interval. And when I do that, I got a negative 0.0125. Put that into my calculator. So I'm going to put that up here in the table. 0.0125. Okay. So if you want to pause the video and try some of these calculations yourself, make sure that you got this down solid, that you can calculate these average rates of change, that's fine. Otherwise, I'm just going to go ahead and put the values that I got in here. 0.015. Let's see, 0.016, and here I got a negative 0.016 again. Okay, so it's kind of looking like the average rate of change is approaching 0.016. So my best estimate of what the rate of change is in the blood alcohol content at 2 hours is 0.016, right? Negative. And it's negative because the blood alcohol content is decreasing, right? The alcohol is being metabolized and there's less alcohol in the blood. So my interpretation of that is that the person's blood alcohol content is decreasing by 0.016 per hour. All right. So that brings us to our general concept here, which is the instantaneous rate of change for a function. So we looked at instantaneous velocity. Now we're looking at instantaneous rate of change for a general function. But it's very similar, right? It's the limit as those time intervals, or those, in this case, again, it's time intervals, but as x gets shorter and shorter around an interval containing the value that we're interested in, right? So we're sneaking up on that value and finding the average rate of change as those time intervals get shorter and shorter. Okay, now you can visualize that as a, as these lines, right? We first of all looked at, a larger interval between A and B, and then we moved B closer and closer and closer to A. And as B approaches A, then we end up with a line that essentially touches at one point. All right. So, so a line that touches at one point is called a tangent line, right? If it touches at 2 points, it's called a secant line, right? But if it touches at one point, it's called a tangent line. And so essentially, the instantaneous rate of change is the slope of this tangent line. Okay. Now you can also look at it as if, we take this curve and we zoom in closer and closer and closer to that point. And as you zoom in closer and closer and closer, that curve, you don't see much of the curve anymore. You're zooming in and you're magnifying that point, and that curve is starting to look more and more linear. Okay. So, and that is the derivative of a function. It's the same thing as the instantaneous rate of change. So the derivative of a function at a point A, and we write it as f prime, the little prime symbol indicates that it's a derivative. F prime of A is defined to be the instantaneous rate of change of the function at point A. And it's the slope of the graph at that point, and it's also the slope of the tangent line to the curve at that point, right? The tangent line touches the curve at a single point. If f is increasing, right? If the function is increasing at x equals a, then the derivative is positive, right? It's increasing because the slope is positive at that point, or the slope of the tangent line is positive. If f is decreasing at that x equals a point, right, then the derivative is negative, right, because the slope of the line, the tangent line at that point, is negative. All right, so that's the big idea here, is that this idea of the derivative of a function. And I will meet you in the next video for the next example.